Hello everyone, myself Kalachelvi, Assistant Professor, Department of Mechatronics Engineering, SNS College of Technology, Coimbatore. So, and welcome to the today's session on factors influencing the choice of electrical drives. So, in real industries, choosing a drive is not simply about selecting a motor. A correct drive selection decides the efficiency and power consumption, and also the performance and speed control, safety and reliability, cost and long-term maintenance. So in this session, we will discuss the major factors that influence drive selection, and we will also connect it with the design thinking approach of the systematic selection. So let's begin. Just recap of the previous session, electrical drives basics. Uh, An electrical drive is a system that converts electrical energy into mechanical energy, controls speed, torque, and position of motors. So, which includes the major components like power converter, motor, control system. So, electrical drives are essential in modern industrial automation because they improve productivity, precision, and energy efficiency. So, the now question is, with so many types of motors and drives are available, so how do we choose the best one? So that is what today's topic answers. So here we take the design thinking part. So to select the best drive best drive, we apply design thinking. So stage one is empathy. So empathize means understanding the user and real world requirements. So we do this by understanding what the operator needs, observing drive usage in real industries, collecting feedback from the users, and finally studying where failures occurs and why they are occur. So for example, a conveyor system needs a smooth torque and continuous duty, but robotic arm needs a high accuracy and quick response. So in the defined stage, we clearly identify the core problem. So we analyze the technical constraints, economic limitations, and the exact drive requirement. So empathize and define stage help us to frame the correct drive selection problems. And then as um, next stage is ideate and then prototype. So here we brainstorm multiple possible drive solution. We explore different motor technologies, different converter and control techniques, and different application scenarios. For example, the speed control, we may think of servo drive for robotics in used, and then DC drive, VFD based induction motor drive. So these are we take as a prototype, which means creating a basic working drive model. So we test the drives under a simulation condition such as low load and full load and varying speeds, starting and braking condition. This helps us confirm whether the selected drive will work practically. This one is, so this is simple mind map for factors influencing the drive selection. So now let's see the overall big picture using this mind map. Drive selection depends on five major factors, that is technical factor, economic factor, environmental factors, application factors, control related factors. So now we will go one by one in detail with example for easy understanding. First one is technical factor. So in this technical factor, we have torque characteristics, speed range, power rating, and then control requirement, and then efficiency. So in this economic factor, we consider the initial investment, operating cost, and life cycle cost, and then return on investment how much, and then budget constraints. And for take it as an environmental factor, we consider the energy efficiency, sustainability, environmental impact, regularity, compliances, and then resource conservation. So the resource conservation, efficient drives conserve energy and reduce operating waste. So the environmental factor ensures that drive selection supports sustainability goals and meet the regulations. This is the industrial applications which we are our drive used. The conveyor system, robotics for a conveyor system needs smooth torque and material handling. For the robotics requires the high precision control and fast response. For the process control like pumps and fans which requires the energy saving variable speed drives. So manufacturing line, we need a reliable continuous operation. So for the heavy machineries like cranes and hoists like it which needs high starting torque and safe braking. So drive selection depends on the nature of application and its working condition. So to conclude, we studied the key factors influencing the electrical drive selection as technical factor, economic factor, environmental factor, application related requirements, control and feedback requirements. And we integrate design thinking of all stages like empathize, define, ideate, prototype and testing. So finally the selected drive must be validated using real world testing and improve continuously based on the feedback. So the final takeaway is a good electrical drive selection is not just about the performance. It must be balanced efficiency, cost, environment and safety and the control. So this is about the selection of electric drive. Thank you.